So today we're going to look at angle pair relationships, and the idea is that by the end of the lesson here you will at least become familiar with these different types of angles, and not only their names but what they are and how what is unique about those particular angles. So we're kicking it off right here with adjacent angles, two angles that share a common vertex and side but have no other common interior points. The way I've always thought of this or taught it is that they're two angles that are right next to each other. So for instance, so if I sketch in this diagram here, and I draw in, so clearly there's two different angles there, okay? The angle here that I'm going to outline in red would be adjacent with, now the angle I'm going to outline in blue. And you'll notice the reason that they are adjacent is because they have a common vertex. I just put that in black there, okay? And they also share one side, and then they're right next to each other. Okay, a diagram that I could draw, and again, you could have saw that down below, clearly, right down here. Okay, now one thing I'm going to show you though is there is a diagram that kind of meets most of the criteria, but not all of it. So if I do something like this, right? I do this now. Understand something. If I trace this guy in blue, and then I trace this other one, let's say, in green, okay, you'll notice those are not adjacent angles. Okay, they do have the same vertex, and they do share a side. However, they're not next to each other. The blue angle is kind of the whole thing, and so they have common interior points. So that's where this no common interior points comes into play. Okay. The next type of angles we're going to look at are complementary angles. Two angles whose sum is 90 degrees. It's that simple. Complementary angles add up to 90. And we'll say that one angle is the complement of another if it adds up to 90 with the other angle. And notice here in the diagram, you can have two adjacent angles that are complementary. We know it's complementary because we know that this right angle box here means it's 90. Or they could be non-adjacent complementary angles as well, where they're not next to each other, but they still add up to 90 degrees. Okay. Supplementary angles, two angles whose sum is 180. Okay, each angle is the supplement of each other. Okay, and again, they could be adjacent or they could be non-adjacent. So complementary 90, supplementary 180. Linear pair. Okay, if you have two adjacent angles whose non-common sides are opposite rays, then you have a linear pair. Okay, so essentially you have a line and you have two angles that make up that line, namely angles 1 and 2. Those two angles form a linear pair. Unique thing about a linear pair is they are always supplementary. All right, and then finally vertical angles. When you have two lines that intersect, okay, angles that are on opposite sides of the vertex is the way I think about it. Now the definition on your paper obviously says two angles are vertical if their sides form two pairs of opposite rays. Essentially I just think of them as being across. So angle 4 and angle 5 are directly across from each other, and angle 3 and angle 6 are directly across from each other. All right, so example 1, given that angle 1 is a complement of angle 2, if the measure of angle 2 is 57, find the measure of angle 1. If they're complementary, then we know the measure of angle 1 and the measure of angle 2 add up to 90. We know that the measure of angle 2 here is 57. All right, so subtract 57 from both sides. I'm skipping a step there, obviously. So the measure of angle 1 is very simply 33 degrees. Okay. Part B, same idea, except now since it's supplement, we're going to be talking about 180. All right, so it says given that angle 3 and 4 are, or angle 3 is a supplement of angle 4, blah, blah, blah. So again, angle 3, angle 4, 180. We know angle 4, so we subtract 41 from both sides, and we end up at angle 3 has to be 139 degrees. Okay, again, I don't think there's anything too crazy unique there. The basketball pole forms, okay, so you have this diagram here. All that basketball pole stuff doesn't really mean a whole lot. Just look at your diagram, okay? Find the measure of angle BCA and the measure of angle DCA, okay? So long story short, we got to solve for x. Well, these two angles form a linear pair, and we just said up on the previous, or I guess it would have been 2 slides ago, that linear pairs are supplementary. So 3x plus 8 plus 4x minus 3 has to equal 180. So you have 7x plus 5 is 180. Subtract your 5. So again, we're just solving for x here. So 7x equals 175. Divide both sides by 7. And I'm going to scroll down a little bit here, give myself more room. So x is equal to, let's see here, we have 20, probably should have had a calculator on me here, 25. All right, so x is 25. And now clearly all I'm going to do is plug back in for x here and x there. So 3 times 25 is 75 plus 8 is 83 degrees for this angle. And 4 times 25 is 100 minus 3 is 97 for this guy. Again, just applying these concepts, these angle relationships to certain diagrams. All right. Find the measure of angle ABC and CBD for each figure. Well, clearly in this first one, we don't have a linear pair, but we know that all 3 of these angles have to add up to 180. Okay, why? Because this is a straight line, and all of those angles, you can't say linear pair because clearly linear pair indicates 2 angles. But we have 3 angles that add up to 180, so we just set it up 11x minus 2 plus 5x minus 4 plus 90 is 180. Okay, and really if you didn't want to do it that way, you could have just said that these 2 angles add up to 90, same idea. Okay, that's where we're going to end up anyway. All right, so you have 16x plus, let's see here, 90 minus 4 is 86, minus 2 is 84, equals 180. Subtract your 84 from both sides. 16x equals 96, divide by 16, x equals 6. All right, find the measure of ABC. Plug 6 in. 6 times 11 is 66. Minus 2 is 64. And CBD, let's see here. 5 times 6 is 30. Minus 4 is 26. Again, we knew that those 2 values better add up to 90 degrees. So we're good. And again, here, I'm going to let you guys do this one on your own. It's a linear pair, so they got to be supplementary. Pretty straightforward stuff. Identify each in the figure below. So identify your linear pairs. Angle 1 and 2, angle 2, and angle 3. Okay, vertical angles, they got to be directly across from each other. So you have angle 1 and angle 3, and really those are the only sets of vertical angles here. You could say that angle 2 is vertical with 4 and 5 together, but that's all we're looking at there. Part B says, are angle 1 and angle 4 a linear pair? Clearly not. Because to be a linear pair, remember, you have got to be adjacent. And angle 1, if I trace angle 1 and then I trace angle 4, they are clearly not adjacent. And so immediately we know they cannot form a linear pair. 2 angles form a linear pair. The measure of one is 3 times the measure of the other. Find the measure of each angle. Draw a diagram. There's a line. There's a linear pair. Okay. If the first one is x, the other one has to be 3 times that one. All right, and what do we know about those 2 angles? We know that those 2 angles added together have to equal 180. 4x equals 180. Divide both sides by 4. So x equals, let's see here, 45. Okay, so x is 45. And so the measure of each angle is very simply going to be 45 degrees. And then 3 times 45, which is 135 degrees. Again, I know I'm going quickly, but you can pause, rewind, and replay this video as much as you need to. That's why I go a little bit quicker maybe than some of you are comfortable with. In part B here, the measure of an angle is twice the measure of its complement. Okay, complement, keyword, 90 degrees. All right, so I know I have one angle, and the other one is 2 times bigger than that one, and I know that they're complementary. 3x is 90. Divide both sides by 3. X equals 30. Okay, so one angle is 30 degrees, the other angle is 60 degrees. Okay, so you're using these angle relationships to set up algebraic equations and solve is what we're doing. All right, so if you have any questions, obviously bring them to class tomorrow, and we'll get those answered right away.